Welcome to another conceptual lesson, inheritance. To understand inheritance, we need to understand an is-a relationship. For example, ice cream is an example of food. We know this because you can eat food and eat ice cream. However, ice cream can also have some extra methods that other food may not, like melt. Because ice cream is an example of food, we define ice cream to be a child class of food. We can also say that ice cream subclasses food. We call food the parent class. Defining this is-a relationship gives us an interesting benefit called inheritance. Now, here's how inheritance works. For all food, we expect to have the eat method. Since ice cream is a child class of food, ice cream automatically inherits the eat method. You can add as many child classes of food as you want, and all of them will inherit the same eat functionality. Let's repeat this analysis with another example. An ice cream truck is a truck. In particular, an ice cream truck has all the properties a truck has and more. As a result, we define ice cream truck to be a child class of truck. This gives us a nifty benefit. We expect all trucks to have the drive functionality or method. Since ice cream truck is a child class of truck, it inherits the drive method too. Finally, ice cream truck can have some additional methods that other trucks don't, like order. In summary, A is a B if A has all the properties that B has. For example, ice cream is a food since ice cream has all the properties of food. This means that ice cream inherits all of food's functionality. By default, eating ice cream is like eating any other food. However, what if that's not true? What if eating ice cream is drastically different from eating other food? In other words, we want to override the default inherited functionality. This is our next concept in inheritance, overriding. Previously, we said that ice cream would inherit the eat method from food, since ice cream is a food. However, let's say that ice cream eating is unique and unlike general food eating. We would need to override the eat method, defining a custom eat method for ice cream specifically. We might want to override eat, because we represent the amount eaten in different ways. With ice cream, we measure amount left in scoops. With other food, we use a percentage. In summary, the child class inherits method from a parent class by default. However, the child class can override or redefine those methods. These two concepts are the core takeaways. We'll cover the last two bonus concepts after a brief summary of what we've learned so far. Our first concept, the is-a relationship, tells us which classes subclass each other. Since ice cream is food, ice cream subclasses food. Ice cream then inherits methods from food. However, we can also have ice cream override inherited methods from food, if need be. For a copy of these slides and more resources, make sure to check out the course website. And that concludes our lesson on inheritance. There are a lot of key ideas in this lesson, but the most important takeaways are the is-a relationship and overriding. Don't worry if the details are muddy. We'll make these ideas more concrete in the next lesson when we begin coding. We'll now cover two more brief bonus concepts. If you're feeling overwhelmed or don't want bonus content right now, feel free to skip to the next lesson. An interface, like the food interface on the right, simply outlines expectations but doesn't provide default implementations. Here, food specifies an eat and an add method but doesn't actually implement either. Ice cream implements the food interface with usable implementations for both methods. Our last concept is an abstract. An abstract also defines expectations for a subclass. However, it may implement some methods and leave other methods unimplemented. Here, the food abstract implements the eat method and specifies an add method without implementing it. Ice cream subclasses the food abstract and fills in the add method implementation. And that concludes the lesson on inheritance, including the bonus concepts. In the next lesson, we'll begin coding some of these inheritance concepts.